All right. So thank you so much, everyone, for joining us for Introduction to AI. Thank you for your patience. We're here tonight with David Peng from Youth Innovation Lab. And thank you for joining us. Again, this will be recorded and uploaded to our website and YouTube probably sometime next week. And please be sure to go online and check our newsletter for all of our other upcoming STEM Academy programs. So David, feel free to take it away.
Sure. Okay, let me share my screen first. And first of all, I appreciate Jessica to give me this chance to make the presentation. At first, it's really something a lot of parents, especially when I am talking with different parents, they're really interested about this topic. And for their kids, even by themselves, they're really have some sort of like the curiosity about what's the AI and what's really the AI for the future, especially something which may confuse them. Not even their kids, even the parents, the adults have some confusing. So I think this is really an introduction of the AI for kids, but if somebody is really just have absolutely no idea about what's AI, or they just like to know a little bit more about what's AI, this is a great chance, and I like to really start from the very beginning level, so everybody can understand that it's really written for the kids, but actually anybody who have interest about the AI can take some point from my presentation, I guess. Okay, let's start just like what I used to do. I introduce myself first. I'm David Peng. I'm the director at Youth Innovation Lab, and I also host a big youth club. It's Youth Coding and Innovation Club, and a lot of parents know my name through that club. Over the years, I host a lot of activities, join a competition, and I also make the presentation seminar like this. And besides what I'm doing, I'm full-time in the IT field for more than 20 years, so I have plenty of experience over there. The STEM education is really my enthusiastic, so I really love to talk with kids, and I like to really gather with them and take them, host a group, then join some sort of the STEM activity. Okay, let's move to the topic what we are talking about. So anybody here can give me some sort of the like movie or music or picture what you saw, which you think it's related to the artificial intelligence. So in short, it's AI. Okay, so in movie, if you saw some sort of robot, right, they are able to talk, they can think like human, and they have the emotion, and they can make the decision like human, something like that. You probably think, oh, that's the robot tried to mimic what a human can do. So it's really the very first, I would say, very first reaction what you get from this kind of movie is that, oh, the AI probably just something like the human. If you see this, they have the eye, they have the arm, and they have some sort of the wheel, just like leg. You think the robot is all about the AI, but actually it's much more than that. Since we are start a little bit late, so I do not really play back the whole video here, but hopefully I play some of this, you can get the basic idea. This video was presented by NVIDIA, one of the biggest companies for the chip maker.
blending art and technology. To immerse our senses. I am a healer, helping us take the next step and see what's possible. I am a pioneer, finding life-saving answers. And pushing the edge to the outer limits. I am a guardian, defending our ocean. And magnificent creatures that call them home. I am a protector, helping the earth breathe easier. And watching over it for generations to come. I am a storyteller, giving emotion to words and bringing them to life. I am even the composer of the music. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
So how about this video? This is really an amazing video which was presented at the WNC, one of the biggest conference for the consumer electronic annually meeting. And this is from NVIDIA. So it gives us some broad sense of what AI really looks like and how it can do for us. Of course, it's really something just try to show its advantage. But let's go back to the fundamental first question, what we may get. So what's really the AI? I know a lot of kids may already saw some kind of robot like this, especially when you hear the name Sophia, which was developed. It's not developed by Saudi Arabia, but it was really give a citizenship by that nation. So it's really amazing. Some sort of the robot which has enough intelligence and we can deal with them just like human. Of course, that's some sort, it's not real, but we still have to prepare for that. So the really question about artificial intelligence is that really something will represent and replace a human? That's a big question we have. So far, what we see the AI is that it must have some of these characteristics. The very first is that it can sense like human. So a lot of scientists take over 20, 30, 40 years try to make the face recognition and all kind of vision to be smart. So that's some sort of the sense, try to really sense like a human. So make the artificial intelligence the very first step. And then the second step, okay, I'm sorry, it's in parallel, it's not step by step. It should understand the human language. So if you really have experience 5 to 20 years ago, we have very few devices which can understand the human language. I still remember that when I had the first couple of like the phone contact with the bank. They ask me to speak my account number. I really amazed. They can understand what I am speaking. But over the time, now they have more and more AI technology, which powered all kinds of devices. They can understand the human language. Not totally, but they can understand much better than it can do 20 years ago. And then the third is solve the problem like human. So if you heard about the AI which played with the human chess player, and the goal, the world champion was beat by the AI, which was invented by IBM. So you can understand they can really solve very complex problems, thinking like the human, and they can even much more powerful than human. So that's really make the whole idea about the AI, not really just try to make something looks like a human. Actually, if you can see a lot of this example, you probably don't really see any sort of the model looks like human, but they are really, at least they can sense like human. So that means they can have some sort of the sensor which can try to detect and try to understand what's the vision in front of them or surrounding of their environment. And they can try to understand the human language. So when you discuss with them, they can understand what you are speaking. And they can solve some sort of problem with just thinking like a human. So that's very, very important. I would say if you understand these three criteria, you probably can identify which one or which device was powered by AI. So now let's do some quick quiz. By these three different criteria, what kind of device or service you are using in your, not every day, just sometimes it was powered by AI. I give you a hint, the Amazon Alexa. So when you speak to them, I use it almost every day. Every morning when I have the breakfast, I always ask them, say, hi, Alexa, latest news. So that means I try to ask Alexa to play back the latest news for me at the very beginning of the day. So that's my experience. So I know Amazon Alexa is AI-powered device. Okay, so now it's your turn. Can you give me some idea what you think some device or service was powered by AI?
Devices?
Siri. Yeah, that's great.
Google Nest?
Yeah, Google Nest. That's a great example because they can have the sensor which can detect a lot of different conditions, right? The temperature, humidity. Yeah, that's a great example. Okay. Yeah, actually, when you bring up the Nest, that's something I will talk a little bit later here. But that's a great example of what you can really try to compare the AI with something only about the sensor. If we only have the sensor, so that means they can detect the temperature, that's not really called AI. AI must have some sort of ability which can solve the problem. So when they really say powered by AI, it must able to solve some problem. Okay, so here is a couple of real life AI example. Of course, it's a very, very long list. We have self-driving car, right? Even you don't have that car, but Tesla has that ability. It's not really fully autonomous yet, but it's close. And we probably heard this name. That's a very big name in the robot. It's called Boston Dynamics. It's really a great, great company which built one of the, I would say, most advanced robots in the world. And you have the navigation system. So it's not, I'm not really talking about the GPS. I'm talking about the GPS with the AI. So that means they can really collect the information. If you use a Google map, you probably can still remember that the Google map can show you all of this traffic. So how do you think they know where is the traffic? So when I go out, I see the Google map show me all kind of traffic everywhere. So how do they know that traffic is there? Do you think that they got all this report from everywhere and they have some sort of the information center which connect and they can update instantly? No, that's not the case. The case is that look, they can really detect and make the calculation coming from all kind of Google Map empowered form. So you send the message back to them and they make the calculation. Then the detect say, oh, this car was stuck somewhere for about 20 minutes, which usually just pass through within 5 minutes. So that's something they collect the information and then they have, of course, it's much complex than what I told you here, but it was really powered by the algorithm. So that's some sort of AI. This is another robot, and even chatbot. Chatbot is very, very popular now. So you have the Amazon Alexa, you have the Google, and you also have the Facebook, right? So they have all kind of device which give you the chatbot, and they have the human and computer game. So that's what I'm talking about. The computer can really try to play against the human. Okay, so we are going back to the very first couple of page, and now we know what's AI. So if you remember that AI, if you don't really know what's AI, you just use these 3 criteria, try to figure out whether it is an AI. I'm sorry. So it can sense, it can understand the human language, or it can solve the problem like human. Okay. So now let's go back to here. What's a weak AI? A lot of times you probably don't really know what's a weak AI, or you don't care. The weak AI really means they are designed to perform the single task. So the single task here not really just refer to one operation or one movement. Of course, it's much more broad than that. But it's really designed to be something very specific, only for one area. So if you see this robot, the whole point for this development of this robot arm is try to do the assembly of this. I'm not exactly sure what's this, but it's some sort of a machine. Okay, so they try to assemble this machine, so to replace the human. So you do not have to have the worker on the assembly line. Instead, all of this robot are doing this. So they must have the sense of the vision, so they can really know where is the object, and they must able to have the very precise control of the arm, so they can move to a certain place which is precise enough to be on the exactly right place, right? Even you thinking about the robot, not robot, the Deep Blue was developed by IBM. It's doing nothing but try to play the chess against the human. So that's even very powerful. It's still something called the weak AI. Okay, so to make it short, weak AI is just try to do one thing and do one thing super good. So that's weak AI. It's called weak AI, but it's not very weak. Or we can call it another name called narrow AI. Okay, so compared to weak AI or narrow AI, we have another term called the strong AI. So everybody knows what's Einstein, right? So one of the super smart scientists which changed the world. And we always have some sort of dream. You can create some sort of machine which can mimic this great smart brain. So can we do it? Of course, we can try it. But so far, we do not really have anything can claim have the strong AI has been successfully developed. It's not true because we are not trying. It's just because it's super challenge. So you can think the strong AI is trying to make the AI just like the human. So they can sense like human, they can speak like human, they can think like human, and they can do everything like human. So that's what the strong AI try to do. It's super, super challenge. And I will say, besides the Hollywood movie, nothing really close to the complete of the strong AI. And that's one of the goal a lot of scientists are working very hard toward to. So besides AI, a lot of times you probably also heard this term, machine learning. So what's really the machine learning? And is that supposed to be the same as the AI? So the artificial intelligence is equal to machine learning? No, actually they are two different fields. The AI, or called artificial intelligence, it really has two parts. One is artificial, another is intelligence, right? So the first word means they try to mimic something. The second word means they try to be really smart. And traditionally, the AI was really designed by try to repeat or find the pattern. And that's really something the human have to interact and have to make some predetermined algorithm. So that takes a lot of human power, and it takes years to train a system and try to create some sort of system to be as smart as they can. So that means everything has been programmed, and it cannot really automatically improve by itself until the machine learning coming out. So the machine learning is really something say, okay, you build a program or you build a system, which it has the ability to learn and improve without a human interactive. So that means machine learning is pretty much try to simulate the human brain. So the human can learn different language. The human can learn how to interact with other human beings, right? So how can we do that? It's because we can learn something, and the learning ability is fundamentally different between the human and some other animal. I know some of these super smart animal can learn a lot tricky, but the human brain is super powerful. So the machine learning, the core of the machine learning is that they can learn and improve without the human's help. Of course, the without here is just some sort of a short answer. The humans still have to do a lot of things before they can start to learn. So that means we develop the program or system which has the ability to constantly improve by themselves. The machine learning is one of the biggest leap in artificial intelligence field. So it makes the artificial intelligence super powerful and become more and more close to what we think it should be. Okay. And I really like this video, but I know we start a little bit late, so I just play a little bit about that. So how the Boston dynamic from the very beginning to the end. So you watch this video, you will see how the artificial intelligence was developed over the time. Okay, so it's really an amazing video, right? We probably see a couple of more video from Boston Dynamic, and one of the big challenge for them is that design some sort of robot which can be really used for different purpose. So that's really very, very challenge. You can see over the time they have a lot of improvement. Okay, so every time we are talking about the AI, one of the terms we cannot miss is called the Turing test. So in 1950s, Alan Turing was really the first scientist which created the first modern computer system. He had a very famous theory called the Turing test. So the whole idea is that try to determine the level of intelligence of a computer. If you think it's not really that hard to understand. So if you have a computer system here and you have another human, for example, you do not really know whether it's a computer or it's a human, you can try to send text message to them, or you can discuss with them some sort of interactive. If you cannot really identify whether the answer is from a human or from a computer system, that means it passed the Turing test. Otherwise, that means fail. Okay, I'll give you a quick example. You have a text message system, right? Or you have like the Facebook, and you can have the message. You send the message to them, and they can answer back. So you ask them the question, and you try to challenge them with different sort of question. You always get a response, and if that response can trick you to think that it's a human being, but instead it's really coming from a computer system, that means it passed, it check mark the Turing test. So this is a very simple way, but it's a super challenge for the system to be designed like this, to pass the Turing test. Because for human, we can ask all kinds of questions. If you want to answer all kinds of questions, it really cannot really be predetermined. So that means you cannot say, okay, I only give them some sort of answer based on your question, because you do not really know what the question will be asked from the player C here. So that's something, if you heard that before, you probably know how it works. And you can try it on your, like a math system or some sort of system. If you can play with a chatbot, a lot of chatbots try to be very smart, but you can still figure out whether they are really just a chat or it's a human. Okay. Since this is for the beginner, so I have to go back to something which have absolutely nothing to do with AI. Instead, we focus on how the computer can think. So when we try to solve a problem, this is really the step we usually come from. So we try to explain the steps, and we need to come out with a solution. So you will break down into a couple of different steps. Of course, you do not have to really understand each one of this. I just give you how the human try to solve the problem, use the computational thinking. So you have to decompose the problem. So that means you have to break into each smaller step. And then you have to find the abstraction. So that means each step you must have some sort of the understanding which you can abstract that. And then you have to able to understand the pattern. A lot of times that pattern may not really be the math. Sometimes it's a visual pattern. For example, you see the ball movement, or you see the car was driving through. So that's all kind of pattern recognition. Then in the end, you build the algorithm. So even you do not really realize you are building some kind of algorithm, but in your human brain, it's really building that. So that's something we call the computational thinking. So it's really, say, our brain think like a computer. Now let's have a quick example about what the computational thinking. So for example, you have the CPR, right? So CPR really refer to give some emergency care. And then the very first step is say, okay, you will call 911. And then the second step is that you lay the person on their bike and then open the airways. And the third one is that if they cannot breathe, start CPR. And the fourth is 30 chest compression. And the fifth is to rescue breathe. And the fifth, of course, is repeat. So that's going back. Of course, you probably don't have to call 911 again, but you definitely need to check this. So going back to number 3. So this is really break down the step which make the big task, how to rescue that person into the step which you can perform one by one, and you can even repeat. So that means it's really define the pattern. And of course, this pattern has been defined, so you do not have to find it, but you are trained to repeat this pattern. Okay, so now let's come over here to what the computer can understand. So the computer can understand the sequence. If you give them the program, say you say, oh, if this condition is true, so if you go back here, if they are not breathing, you start CPR, right? So it's exactly replacement here. So if they cannot breathe, you start a CPR. Okay, then this part is you make the decision. And of course, you have a loop, just like here. If it didn't really work, you repeat until the ambulance is here. So that's the same thing. You repeat the CPR and you check the condition. If it's not breathe, you do the CPR again, and you, of course, they have a couple of steps, more than that. So the chest compression, something like that. So this is really the flow of execution, which the human can repeat. Of course, the computer here can repeat as well. So now we bring in the programming part. Since this seminar is not really trying to teach you how to program, instead it's trying to give you the introduction of AI. So I don't really go into too much details. This is really a very quick example about how to find the square root of a number. And of course, you break it down into different steps. Say, okay, you get a number. And if this number is less than 0, so you will repeat this. And if this is smaller than n, you will print out this. Otherwise, you're going back. So this is really something very similar like what we saw here. It's a flow of execution, right? So when we really write this, what we call flow chart, you can start programming. Say, oh, you enter the number, and then you try to get the answer. And inside that, you repeat and try to figure out whether they are really close by to be the answer. So that's really, this is really the implementation of what you are create here. So this is the coding, and this is really something which you can, you do not really have to draw it like this, but at least you can think like this. So this is really the flow chart. Of course, when it's really running like this. Okay, I think I'm start a little bit late, so I do not really show you this example. But the general idea is that you can think from the computational thinking, break down the question into smaller steps, try to find the pattern, and try to define the algorithm. And when you have something like this, you can implement, use coding. This is really something use the Scratch, but actually you can use Python, Java, or whatever programming language you can choose or you are familiar with. Okay, so now let's go back to something we are all probably heard before, or at least know it. So when we try to create some sort of game, a lot of times we try to make it interactive with them. Just like you have the Wii or you have the PlayStation game, you know you can interact with the game, right? A lot of times, you shoot and you can jump, and they can detect your movement. And interactive game makes a lot of fun. It's because they have the sensing. So I will show you something which is very common for the Scratch. Okay, I come over here to show you from one of the example here. Okay, let's move down to here. Okay, so I have a quick example here. Try to make this bigger. If you never really create some project use the video sensing, I will go through the very basic stuff here as an example. So this is really a demo for you. Okay, so let's try to start play with it. I start from here and ask me what's your name. So my name is David. Cool. And then I try to wave my hand. Okay, let me see if it's really start or not. David. That's interesting. You don't really interactive with me. Let me see if I already have this computer allowing this. Okay, so this part is very important, especially when you are trying that on your PC or Mac. You must make sure you allow this program to access your microphone or access your camera. Okay. So this is something which I have to be very careful. A lot of times it didn't work just because they do not able to detect your microphone or camera. Okay, let me see if I can repeat it again. Okay, let's see. Continue allowing this to access your microphone. Always have the microphone access. Okay. I know what. Yeah, that's maybe because my microphone has a problem here. Okay. Yeah, in case I don't be able to show you this, I will just give you some basic idea of how I make it work. Okay. Yeah, sounds like they have the problem to detect the microphone here. Okay. But anyway, I go through this first. So if you have interest in, I can share this program so you can try it. Hopefully you can make it work. The sensing block is from here. So we have two different sensing. The first part of the sensing is here, which you can really have all kind of block to detect the touch different color, or you can check if one color is touching another color. And of course, you can detect whether the mouse was moved. They have all kind of property over here. But much more than that, I want to really show you is really the video sensing part. So the video sensing, it's really a totally new extension. So just in case you are not sure enable the video sensing yet, so you can click here, add extension, and you can add this video sensing. So this is a video sensing. And each one of this, I will break it down. I'm sorry, this is kind of small. So going back to here, the video sensing extension for Scratch is really try to use the video camera, your built-in or external video camera as a sensor to detect the motion and color. So when you create some sort of project like this, they can detect the motion, the movement which you made in front of the camera. So they can really see the visual characters overlay of the real world context. Okay. I'm going to here, so you do not really have to skip this. So the very first one is that you have to install this video sensing extension. After that, you have couple block. They have 4 blocks here. If you see here, it's the same. So the very first one is that they detect whether the motion was, the movement was detected by the camera. So it's from 0 to 100. So it's the amount of motion. You move faster, they will give you a bigger number. And the second one is a variable block. So it can detect the amount of motion on a specific spirit or entire background. So just like this, you can choose one spirit or you can choose the whole stage. So that means the whole background. The whole idea is that they try to figure out whether you are really have the motion around this spirit or you are have a motion for the whole stage. And of course, before that, you have to turn the video on. So this is turn the video on. And you can set the video transparency from 0 to 100. This one is a little bit tricky. This one means you can set the transparency of the background on the scale from 0 to 100. 0 means totally transparent. 100 means complete white background. So I will show you another different example so you will see how it works. And it's really some sort of like the blending. Okay, let me go back here. Okay, so this is the second. Let me start from the first one first. Okay, so this is a very typical fishing project. I built a couple of fish. If you see that, each fish has its own script. So that means it has its own code. And I will break it down so you can see how I program it. I'm not 100% sure whether it will work here, but if it works, it will be something I can show you. Okay. Okay, so the detect 0, but they don't really detect anything more than 0. Okay, let's try to raise this. So this one probably. Okay, so this one. Okay, nice. Again, you have to check this icon first, so it will allow you to use the camera first. So this camera was here, and unfortunately, my connection here has a problem. So I will explain the coding part instead of take too much time to try it. Okay, so for the first fish, so this fish, you can see here, what we are doing is that when they are detect the video motion larger than 20, so they will start to play the ocean wave. So this is ocean wave sound. Right? And then it goes into a forever loop. When it really detects the touched edge, so the fish can really swimming over here and go touch the edge, then they will point to another fish, to the fish 2. So this is fish 2. So when it touched the edge, they will going back and try to chase this fish. Okay. And then it's repeat, move 10 steps, something like they'll slowly move step by step. Okay. And then we can see what the second fish is working. Okay. Try to make this big enough so you can see it clearly. So the second fish is this one. So when you click this, and you are really trying to detect the motion which towards this spread. So that means they are really trying to see if you have your motion was over actually this spread. So if it's really some motion, for example, you have the hand wave over here, they can detect this. When they detect this motion is larger than 20, so that means you will move fast enough. They will go to random position. So go to somewhere randomly, and then they will wait. So if it's on the edge, they will bounce back. So this part goes bounce back. Okay, so now let's go to the third one. Okay, this should be enough. The third fish is this fish. So if you can see this fish, when they detect the video motion was larger than 20, they will change the transparency to 60. And then they will play the sound bubble. Okay, so let's see what the sound bubble sounds like. Okay, so this is bubble sound. And then in a forever loop, they will detect whether they touch the edge. If it touch the edge, the coming back try to chase the first fish. So they try to chase this one. And then they will set the language to be English. And then they will speak something and say, hello, nice to see yours, because he tried to follow these two fish, right? So this is how the whole program works. And I can release the code to you. If you have a chance, you can try it out. Very important is make sure your camera is on. Okay. So this is really something which I made as an example. Unfortunately, I have some tech issue here. But if you can see here, it's really transparency is like this. So if you set transparency to be 0, so that means it will be totally blending here. Your own image will be captured through the web camera, and it will blend into your current background or core stage. If it's really 100, that means they will totally wipe out. So that means they will not really have anything here. Okay, this is really the code what I just explained to you. And since all of this are really something which we use a video camera, but how to detect the motion and how to really detect the voice. Even you are really detect the motion, touch the spirit. It's really some sort of the intelligence. It's not a very good example for the AI, but as a beginner, if you really get it works, you have at least understand a little bit about, oh, the motion over the spirit can be detected by your video camera. So that's some sort of the intelligence it was built in. Okay, so now we are really going back to the more advanced AI example. The whole idea about this seminar is just try to give you guys some basic understanding of what's artificial intelligence, right? So one of the advanced collection of the AI example is what I call the AI experiment by Google. So if you really go into this URL, please try to follow with me. And let me see if I can make this bigger. I'm sorry. Okay. So if you can see this, probably you can see it's clear. Okay. So if you can type in this, you can follow with me. And they have a lot of smaller but a very advanced AI example provided by Google and its partner. I say it's one of the best connection what I can see, especially for the beginner. You do not really have to understand how it works, but it's really important for you to understand what the AI can do and what they can do so far and what's the restriction sometimes you may find. Okay. Now let's go into the example. What I want to show you is how to identify the image. So if you think the Tesla can do the atomic drive, so that means the automatically drive your car, the Tesla, how can you do it? Anybody have any idea about how the self-drive car works? Or you can give me some of your understanding and say, I think it works because this and this. Okay, I'll give you a hint. So for a car to drive without driver, what's the very first stuff that has to do? Or say, when you are really a human driver, even you are not driving yet, but you sit next to your parents or sit in the back seat. So you know how your parents are driving, right? So how do they really behave like humans drive a car? Or say, what kind of sensor we need to drive a car without human? I think a lot of you probably already know at least one of the answer, right? It's not really super challenge. You must have some sort of human eye, right? Without the eye, how do you able to see and identify? So that brings the very first question. With the human eye, what we can do is that we can identify where's the road and where's the object and where it's really something which we found it's some sort of object which can cause the accident. Or sometimes we just saw a pothole, but it's not really cause an accident. So it's very, very important. The human eye can really see and find the object. Also, they can identify the object. It's called the categorize. They can really categorize that into, oh, this is really the car, and this is really the cops, right? And this is really the cat, and this is really the dog. Or you can say, this is a human, and this may be some sort of animal. So it's super important, right? For the automatic driving car, you must able to understand and identify the image. Okay, so how can we do it? So this is how it works for most of the case, not 100% time, because I don't really know all of this algorithm, but I give you some very basic step-by-step algorithm, how they identify the image. The very typical image identification project will be something like this. They will find a lot of pictures and tag it. So for example, we want to identify whether it's a cat or it's a dog. So we collect probably 2,000 of the cat picture, and we collect another 3,000 of dog picture. We find all of this picture, and then we give them the tag. The tag means, okay, this picture you say, you give them picture, say this is cat, and this picture you say this is dog. Okay, so that's a tag. So one of the very first challenge question I ask you is that why we need to give each image a tag? Okay, so I guess you probably don't really know the answer, but doesn't matter. I will give you the answer later. And so just assume we have all of this picture with the tag. The tag just means a name. So this cat, this dog, this cat, this dog. Okay. And then step number 2 is that we need to train the AI system. So now we have thousands of pictures of cat, thousands of pictures of dog, and we have each picture have its own tag. We give to the AI system, we train. So how do we train a baby to identify the items? Anybody, if you have the siblings in your home, do you know how to train a baby to identify an item? Okay, so when you really have chance, next time, if you really have chance to see some baby over there, you can see how the baby identify an item is that they are really identify the item by learning. So when you see the mom speak with the baby, the mom usually will say, "Oh, this is a cat. See how cute this cat is, right?" Or say, "Oh, that's a dog. Just be careful. Don't be too close to that dog. It probably is a big dog." Okay, so the baby are really identifying the items by learning it. And who teach them? Mom, dad, or the brothers, sisters. So they all give them the tag, say, this is a cat. The tag is a cat. So he or she, as a baby, will develop the system, try to identify that item. The human is just like any kind of AI system. We are learning that by training our brain. So this part is exactly the same. We are really learning by identifying a lot of items piece by piece. Then we can identify, oh, this is a cat, this is a dog, right? Okay, in the end, I can show you one of the, I'm sorry, I don't skip that. The number 3 says learn and test AI. Just like what we ask a baby to identify the item of training them, right? So I don't really supposed to say training, but actually it's learning. Okay, so we are really ask the baby to learn how to identify the cat or dog. They are really doing the same thing, like the label each of this image and then go through different layer. In the end, they build some sort of pattern to identify. They know, okay, this is a cat, this is a dog. It's the same thing, exactly the same thing. They are learning and then they can test. Sometimes you can see the mom probably ask the baby to give the feedback, say, oh, do you know what's that? Oh, the baby may say, oh, it's a cat. Okay, that's great. So the baby can identify the cat, right? Sometimes maybe gets it wrong. He probably thinks the dog is a cat because they are small dog, looks like cat. It's okay, we continue to train them. So it's exactly the same thing like how the baby identifies the item. Okay, so now we are playing something very interesting. I really like you to play with me. I copy this and drop over here. Again, this one was developed by Google. It's called the Vision API. But one of the very cool things is that it can drag and drop, and then they can try to understand what's that image. Okay, now I stop here for a couple of seconds so you can type in that in your computer. Please try to start a browser and type in this one. I think this is big enough, so you can see it, right? I want you to play with me. Okay, 5, 4, 3, 2, 1. Okay, now let's start. And I going over here. If you see this page, they have tried. That's definitely just some experiments. You can do it. You can drag a picture or you can browse from your computer. I have something I already saved, so I have a picture already downloaded. But in case you don't really have your own picture, you can go over here and say, okay, you want to download a bird picture. So you go to type in the Google bird and then go to image. And then you can find all kind of bird picture, right? And I just quickly, okay, save as. Okay. So this is the bird one. Okay. Now let me drag this picture from here, from my local folder over here. I have the first one is a cat. Okay, so this is a cat. I really love this cute cat. I have another cat, but it's not the same, but I want to show you. Okay, so now you can see the result from this regression set cat, 98%. So that means they try to understand what's this object. This is a cat. It's 98% correct accuracy. And they have all kinds of labels. So say, okay, for cat it's 95%, and they have another name. I'm not even sure what this really refer to. Probably some sort of cat. Maybe this breed of cat is carnivore or whiskey or fawn. So this different kind of cat, right? And they can even tell you this is a small to medium-sized cat. So this is very, very cool, right? And you can see here that have another label for this picture is called wildlife. It's a wildlife, so you can think, they even think it can be a toy. Of course, this is not a toy, but anyway, it's not 100% correct, but it's really something which they can show you all kind of label they give to this picture. Please try it with me. Okay, so let me try another picture, another new file, and this time I give a dog. Okay, so now you can see, they say, okay, 96% this is a dog, and we can see what kind of label they have. Say 96% this is dog, so it's pretty much it's a dog, and they have dog breed, and they have companion dog. Oh, great! So they know it's a companion dog. It's a walking animal. I don't really know what that refers to, but maybe they say it's possible a toy dog. Maybe the toy dog can be looks like this, right? And they even found its breed. Of course, I'm not 100% sure whether it's really Terrier, but somebody knows dog much better than me. Okay, so now let's try another one. This time we try to find 4 animals together. Okay, so this is quite interesting. You can see they have the dog, they have the cat, and they have the animal, right? So they know which one is really a dog and which one is really a cat. If you give the label, they can say, they found a lot of label inside this picture. They found the color brown, they have the dog, they have the cat. They're very sure they have the dog, they have the cat. And they even have different kind of cat. Have the small to medium-sized cat and have the companion dog. So they know this dog may be your good friend, and they have found the dog breed, right? And of course, they think it is an animal figure, and it may be a photo capture. Of course, this is photo capture. So they have different labels. The higher percentage means they are much more sure about how it is. Okay, so now let's try another one, just see if it can find it. Okay, so this is a bird. And if you see that, besides birds, they also found the pig. They found the wood, right? Great. And they found the feather. And songbird, I'm not really sure whether this is songbird, but anyway, let me say he probably very smart. They can understand how it is. So this is really something I want you to try. How the vision API developed by Google can identify and really understand the picture. So one challenge question is that, how do you think the Google can develop this system to be so smart and they can understand all kinds of different animals or objects? So this is a challenge question. Anybody can give me an answer. So how do you think the Google can develop the system like this? Okay. I give you my quick understanding is that there are not really much more than this steps. Step number one, find a lot of pictures, tag it. Step number two, use that picture with tag, train the AI system. Step number three, it's learning and test the AI. So every time we are really doing something like this, it's really test the system. So they are constantly learning, right? This picture is much more complex. So that's why they give you a lot of different labels. And the overall confidence is not very high, but they can find a lot of objects. So you can see they have the object here, here they have the toy and where, and this they don't really understand very good, and they give you a lot of labels. Label means whatever the object they find inside this picture, they try to give label. So that means they have found the chess, right? Great. They found the chessboard. They found the food. Yeah, here. They found the hood. Huh? Yeah, they also have the hood. Technology, of course, this is pretty much technology related. And they have the motor vehicle. They have gadget. They have all kind of keywords which associate with this picture. So I really want you to play with me and try it by yourself and try to understand how it works. This is really fun. Okay, so we have go through this experiment. It's Google's Vision API. And the last couple of minutes, I want to show you something a little bit more than this example. So the very first one, I stay here for a couple of seconds. If you want to follow with me, you can try this out. It's called the semiconductor. Okay, I'm not really sure whether I can show you how it works here today, because it looks like my camera connection with this computer has some sort of problem. At least it detects has problem. So the semiconductor means the conductor an AI orchestra through the browser, but actually it can check, okay, make the orchestra play by moving your arm. I will try to move my arm, just see if they can detect it. Move down and up to play louder and soft, okay. Move from side by side to control which section to play. Let's go. Okay, let's see. Let's see it's conducted. Please connect to the web camera. Oh gee. Okay, looks like they have some sort of problem to connect my web camera. Yeah, that's unfortunately the case. I tested yesterday night, but in case you can use your web camera, please try this. I'm sorry. Please try this one. I give you the URL. The whole point is that they give you the chance to move your body like a conductor. The conductor really uses the body language for the whole orchestra, right? So you can see the violin, viola, and bass, and you can really give them the direction, and then they can change it. It's really very fun and interactive. So one quick question is that, how does it identify the body movement? So when they try to play with this, they really detect your body movement, your limbo, move up and down, move left, right. So this is really something, the very first step. They must make sure they can identify what's the movement you are doing. After that, it's pretty straightforward. So if you move from left to right, they think, okay, you are pointing to this section, so the bass start to play. Or you move to the right to left, they will say, okay, violin start to play. Or if you move up, they will say, okay, play louder. If you move down, they say, oh, just play quieter. So that's really something all based on the body movement. Okay, so the number two is that create a fun animation, use the real time from the camera. Okay, so this one is another one I really like to show you. I hope it will work. I'm not 100% sure, but if you want, you can try with me. So it's really try to create some sort of dot. Okay. Choose a shape and then try to scrape it. Make it move your body, and then they will try to detect that. It's very bad. I have a bad day today. I cannot connect my camera, but anyway, if you can connect to your camera, please try. Okay. So this is really try to create that based on your movement. If you see how it works, you probably can see the image, what they created. So if you see this, it's really the image what they created. So based on your movement, they will try to create all sorts of the image. Okay, so that's how it works. They even have application for your phone, so you can really use that to create all kind of cartoons. So that's very fun. So one quick question: how can they mix your face with this dotted? So they'll create something like this. They create some sort of head and your hair. Of course, that's not real hair. So how can they mix it? It's not really super challenge if you're thinking about that. They take your picture here, right? So you are sitting in front of the camera. They take your picture, and then they can really try to add one more layer, which is just draw like a cartoonist, which as long as they can detect where is your human body, they can do it. It's not super challenge, but it's challenge enough for most of this program. You still have to be very specific, and you have to be super smart, super intelligent on detect correctly. Okay, so the last one is turn your photo into a cartoon drawing. Okay, so this one, I believe we can try it out. Okay, since this will take a couple more minutes, so I'm not quite sure whether I can show the end result to you. But anyway, I upload a picture. So I upload a quick picture, which should be simple enough. This one, it's a dog. Okay, and then they will start loading and try to create a cartoonish from this picture. Okay, cool. This time it's not very slow. I don't know why they don't really show me. Let me download it. Then I can show you how this looks like. Oh, I know what. Yeah, because this picture is pretty much use the white background, so that's why they are not really able to identify it correctly. Let me try this one. This one maybe not very good. How about this one? Yeah, usually it takes a little bit longer time to render and generate that picture. I mean the cartoonist picture for you, but hopefully this time it can be fast. I'm not really in a very good lucky day, so they don't really. Oh, they still use the bug one. So this is not very good. Okay, let me see if it has some sort of. Okay, I can show you how it works. Like. This one, okay. Yeah, this is how it works. So if you see this, it's really generated by the picture. So if you have a picture, have two persons with a dog, they can really abstract that and try to build that as a cartoonish for you. Something a little bit better is something like this, but in general, they don't really create such a precise picture because they're not really as good as a human can be. It's really I would say it's a very beginner level of the cartoonish, but if you can create, if you can use a picture very specific, it can be very good output for that. Something like this. This is a turtle, right? So they try to chase something. Unfortunately, we are not really able to see it. Okay, so that's pretty much about the presentation, what I want to show you tonight. And if you have any questions here. Okay. Yeah, I'm sorry. I don't really hear any background noise, so I'm afraid to drop.
No, it,
Yeah,
it doesn't
not-
look like, yeah, it doesn't look like there are any questions. I'm not seeing anything in the chat either.
Okay, cool. Yeah, as long as it's not drop the call, so that's good. Yeah, I try to be interactive with the audience here, so I ask a lot of questions. Of course, sometimes they may not really able to give the right answer, so that's why it's okay. Yeah, that's pretty much the introduction of the AI for beginner. I will not really only target as the kids, even the adult, if they have interesting to know a little bit about AI, I think this is a very good seminar for them. They can understand all kind of AI and how we are really going from the beginning at a very rough and a very unclear picture back to 20 years ago. The AI is still premature. Now we have a lot of applications which are very, I would say, very advanced. If you think about the Amazon Alexa and Google Assistant, they can really understand almost all of these questions you ask them. Occasionally they misunderstand you, but for most of the case, what I can tell is that they're pretty good. They understand most of this. My son even used Google Assistant for translation. So sometimes he tried to understand from different language, or say translate from English to Spanish. He will try it. So that's pretty good. Okay, so yeah, I think this wrap up, and this is end of our seminar. If you have interested to know more about this topic, please contact Jessica and let her know. And I have this GPT I can upload somewhere and share it. And if you have interest in, definitely you are welcome to check the YouTube, from upload by the Levittown Public Library. And next week, I have another seminar talking about Java programming. Again, it's not really the teaching course, it's really the introduction, just for you to understand what Java can do and what's the history of Java and what's Java language, why it's getting so popular and why it's important. So I hope next week you can come back and join that seminar as well. Okay, and Jessica, do you have any other statement or you want to give the ending?
Yeah, thank you so much, David, for joining us. That was a great presentation. It was really interesting. As David said, we have another session coming up on the 23rd. We're actually doing Python coding next time, and Java is on July 30th. So they're all on Fridays. They're all on Fridays from 5 to 6:30. Registration for all of our STEM sessions is open, so please feel free to register if you're interested. And again, as David said, everything is being recorded and it will be uploaded to the library's YouTube account as well as our website. If you have any follow-up questions, you can email teens@levittownpl.org. You can always call us and we can forward the questions along to David for you. So thank you so much for joining us and have a great night, everyone.
Thank you. Have a good night. Bye.